Hi everyone. Today we're going to talk about geometric series. And before we get into the notes, I wanted to give you a little intro into where the formula for a geometric series comes from, because in your notes we kind of just jump in right with the formula. And so I want to show you a little bit as to how it's derived. Okay, so let's just start out with what is a geometric series. Okay, so geometric series very similar to an arithmetic series is the sum of the terms of a geometric sequence. And we looked at geometric sequences yesterday. Okay, so let's say, for example, we have a geometric sequence where the general term is this, Tn, and I'm just making this up, equals 2 times 3 to the n minus 1. Okay, so 2 would be our T1 or our A value, that's our first term, and 3 is our common ratio. Okay, and let's say we're looking for S5, which is the sum of the first 5 terms. Okay, so what we could do, one option obviously is to just write out the first 5 terms. So T1 is 2 times 3 to the 0, which is just 2. T2 is 2 times 3 to the 1, which is 6. T3 is 2 times 3 squared. So that's 9 times 2 is 18. And also we're just multiplying the previous term by 3. So we could do it that way if we're going consecutively. T4 is 2 times 3 cubed. So that's 27 times 2 is 54. And T5 is 2 times 3 to the 4. 3 to the 4 is 81 times 2 is 162. Okay, so one option to get S5 is to just write out the first 5 terms and then say, okay, S5 equals 2 plus 6 plus 18 plus 54 plus 162. And that's always an option. But if we wanted to know like S300, that would be really time consuming. And so what we're going to try and do is come up with a general formula that will allow us to find any sum without having to find the individual terms. Okay, so what I'm going to do is I'm going to multiply this entire line, what I just found for S5, by 3. And 3, remember, happened to be the common ratio. Okay, so I'm going to multiply this whole thing by 3. So I'm going to go 3 times S5. That should equal all of these terms multiplied by 3. So 3 times 2 is 6. 3 times 6 is 18. 3 times 18 is 54. And you can see what's actually happening is that this term above is just kind of moving over 1, right? So 3 times 54 is 162. And then we have to figure out what 3 times 162 is. So I'm just doing that on a calculator. 3 times 162, that's 468. Okay. And now what I'm going to do is I'm going to subtract these 2 equations. So I'll start with the larger one, 3 times S5, and I'll write these all out again. And I'm actually going to stagger this a little bit this time. So I'm going to move the 6 over a little bit, leave a little bit of space. 6 plus 18 plus 54 plus 162 plus 468. And then I'm going to take the second equation, which is S5 equals 2 plus 6 plus 18, etc. And I'm going to write it a little bit staggered so that the numbers that are the same are actually right underneath one another. Okay? And now what I'm going to do is I'm going to subtract. So if I subtract, this is kind of like when we're doing a solving a system, right? Similar sort of idea. On the left side, we're going to have 3 times S5 minus S5 equals, okay, now I'm going to start at the end on the right. So this is like 462. I'm actually going to, I know that these aren't in here, but just that we have something to subtract, I'm going to add these in. Okay, so 462 minus 0. I'm sorry, I think, oh, this is wrong. It's not 462. I don't know why I read that wrong on my calculator. This is actually 468. I thought that looked wrong. Okay, let me erase that. There we go. Let's fix that. This is no, not 68. 86. There we go. Third time's a charm. And I had it right here. I inverted the, I think there's something going on with my brain, you guys. I inverted the last 2 digits. I switched them around. Okay, 86, that's better. Whew, all right. So 486 minus 0 is 486. Okay, and then 162 minus 162 is 0. 54 minus 54 is 0. Whoops. 18 minus 18 is 0. 6 minus 6 is 0. And then 0 minus 2 is -2. Okay, so you can see all of these terms in the middle actually cancel each other out. Okay, and what we're left with is just this first one and the last one. And that last one, even though we didn't need it to add the terms in the series, was actually T6. It was the next term in the sequence. So I'm actually going to write that out over here. T6 equals 2 times 3 to the 5, which is 486. This time I'll write it out correctly. Okay. Now I'm going to simplify this a little bit. And what we end up with is here, I can actually factor out an S5, or sorry, the 5th sum, and I'm left with 3 minus 1. I know it may seem a little odd to do that because you could just say there's 2 S5, but what I'm trying to get to here is a generalization. So we'll see in a minute why this is useful to do. And what we're left with on the right side is 486 minus 2. Okay, now if we go back to our original Tn, okay, this is T1. Oh, sorry, no, this is not T1. What am I saying? This is R. This is R. Let me erase that. That's the common ratio. This is T1, right? This is T6, and T6 is 2 times 3 to the 5. That's T1 times R to the 5. Okay? So now what I'm going to do is I'm going to rewrite this whole thing out using these values from the sequence instead, using these general values from the sequence instead of the actual numbers, because what I'm trying to do here is work to a general formula that will work for every sum, not just for this specific sequence. Okay, so here's what I have. I have S5 times R minus 1 equals T1 times R to the 5 minus T1. Okay, now what I can do on the right is I can factor out a T1. So I'm going to do that. S5 times R minus 1 equals T1 times R to the 5 minus 1. And then I am going to divide everything by r minus 1 because I want to solve for the sum, right? That's what I'm after. And what I end up with is that S5 equals T1 times r to the 5 minus 1 over r minus 1. Now notice the 5 and the 5 match. So if we want the general formula for the nth sum of a geometric series, it's this. Sn equals T1 times r to the n minus 1 over r minus 1. Okay, that is the general formula for the nth sum of a geometric series. Okay, now sometimes you'll see it written this way. Okay, and all that's happened there is that we've multiplied the numerator and the denominator by -1, right? Because the factors in each, the order of the terms switch. When you multiply by -1 over -1, you're just essentially multiplying the whole thing by 1. Okay, so you'll see both versions of this. All right, so now we are going to head over to our notes. Oh, and by the way, I should mention this as well. The r value cannot be 1. The common ratio cannot be 1 because if the r value is 1, then we're dividing by 0 in the denominator, and we can't do that. Okay? All right, so let's go over to the notes and we'll continue there and look at how we can use this. Okay? So here we have the general formula, and I'll just write this other version that we saw as well, where we switch the order of the terms in those two brackets. Okay, so let's look at some examples. Determine the sum of the first 8 terms of the following geometric series. Okay, well, to determine the sum of the first 8 terms, we want S8, okay? To determine that, we need to know what T1 is, and this is T1. And we need to know what R is. Well, it looks like what we're multiplying by is times 3. So R equals 3. Okay. Once we know those two, we can just plug those values into our formula, and we will get that S8 equals T1, which is 5, times R to the 8, or sorry, 3 to the 8, because I'm going to actually fill in values here. In general, it's R to the 8, but we know what R is. It's 3 to the 8 minus 1 over R minus 1. 3 minus 1. Okay, and that works out to be 5 times 3 to the 8 is, let's see, 6,561 minus 1 over 3 minus 1 is 2. And when I put that into a calculator, I get 16,400. Okay, so that would be the 8th sum of that geometric series. All right, here's another one. Here we don't have a bunch of the terms, but we know what the first term is, and we know what R is. Okay, so here I'm just going to plug in S8 equals 54 times. Now, in terms of when do I use either of these two formulas, I tend to use the second one when the R value is less than 1. Because when the R value is less than 1, then the numerator and the denominator will both be positive. Okay, because think about 1 minus a quarter is going to be 3/4. Whereas if you go in the denominator, a quarter minus 1, you get negative 3/4. Now you're going to get the same value no matter what, because you'll just get a negative over a negative, but that's just my general tendency, and you can do whatever you want. Okay. And you can put this into your calculator and get to know your fraction button, because you may be asked for an exact value. So 1 minus a quarter, that's 0.25 to the power 8 times 54 divided by 3/4. Okay, and then I'm just using my math, and then I go number 1 to fraction, and I actually get as an exact value 589,815 over 8,192. Rounded, it is about 72. So this is rounded. This is exact. You may be asked for either. Okay, so you got to know, you should have learned how to work with fractions on your calculator in previous courses. If you're not sure, then please ask, because you may be asked for an exact value. Okay. All right, let's look at a couple more examples. Determine the sum of each geometric series. Round to the nearest tenth. Okay, so now here we know that we can round, so we don't need to find the exact value. Okay, now here the problem is we don't know what n is. So we could figure out T1, right? T1 is 1 over 64. We could figure out R, because remember the common ratio is just one term divided by the previous term. Okay, so R is like Tn divided by Tn minus 1. So I could take any two terms. You could go a quarter divided by 1/16, the 16th divided by 1 over 64. It doesn't matter, right? Maybe I'll go 1 over 4 divided by 1 over 16. Okay, and then, that's just like multiply by the reciprocal. 1 over 4 times 16 over 1. That's 16 over 4 is 4. So that's R. R is 4. T1 is 1 over 64. Okay, now here we actually have to work with the sequence to figure out what n is, right? We know what Tn is, we know what T1 is, we know what R is. We actually know that Tn equals 1024, and we want to know what n is. Okay, so remember that Tn equals T1 times R to the n minus 1. So let's fill in what we know. We know that Tn is 1024, and that's equal to T1, which is 1 over 64, times R, which is 4 to the n minus 1. And now we've got to solve this for n, right? So what I'm going to do is I'm going to multiply both sides by 64 so that I undo the 1 over 64 on the left. So if I do that, then 64 times 1024 is 65,536, and that's equal to 4 to the n minus 1. Now the idea here is that if you can figure out like this number 65,536, could that be written as 4 to the something? Then you could figure out what n is, right? So I'm just going to play around and I'm going to go, okay, what's 4 to the power 10? Oh, that's higher than 65,536 because it's like 1 million something. Okay, 4 to the power 7. That's too low. So I'm going to keep going. 4 to the power 8. 4 to the power 8 happens to be 65,536. And I'm just doing this on a calculator. So I can replace it with that. Right? Now, I can conclude that 8 has to equal n minus 1, which means n equals 9. Okay, so what I'm looking for here in terms of the sum is I'm looking for S9. Okay, so S9 is T1, which is, actually, let me just go straight into it. 1 over 64 times 1 minus, or r to the n minus 1, so 4 to the 9 minus 1 over r minus 1, 4 minus 1. Okay, and that works out to be 4 to the 9 minus 1, let's see. Okay, so that's 1 over 64 times 4 to the 9 minus 1 is 262,143 over 4 minus 1 is 3. And when I do that all on a calculator, so rounded, I'm getting 1,365.3. This is rounded. If I want exact, I can use my fraction button. And of course, I wasn't asked for that, but I can find it. So exact would be 87,381 over 64. Okay. But this was the value that was asked for in this question. All right. Okay, so for B, this is a similar type of question. Again, we know what T1 is. T1 equals -2. We can figure out what R is because R is just one term divided by the term that comes before it. So let's say we go 4 divided by -2, that's -2. And we know that Tn equals -8,192. Okay, so I can now figure out n, right? Because I know that Tn equals T1 times r to the n minus 1. So I'm going to plug in -8,192 for Tn, -2 for T1, and -2 for r to the n minus 1. Okay, and then I can divide both sides by -2, and I'm going to get 8. Okay, so -8,192 divided by -2 is 4,096. -2 to the n minus 1. So again, I'm trying to express 4,096 as a power of -2. Well, if it's a power of -2, it's got to be even. So that helps me with some of my guessing. So I might try like 2 to the power 10. That's too small. It's 1,024. So I might try 2 to the power, or -2 to the power 12, right? And that happens to be 4,096. So I can replace this with -2 to the power 12 equals -2 to the n minus 1, which means that 12 equals n minus 1, which means n has to equal 13. Okay, so now I'm finding the 13th sum. Okay, so S13 is going to be T1, which is -2 times R, which is -2 to the 13 minus 1 over R minus 1. Okay, and I'm just going to do that on a calculator. So I'm getting, let's see, -2 to the power 13 minus 1 times -2 and then divided by -3, I get, whoops, negative 5,462. Okay. All right. One more question and then we'll be done for today. All right. The format of a Scrabble tournament is such that the losers of each round are eliminated from the next round. The winners continue to play until the final match determines the champion. If a tournament has 512 participants, how many matches will be played? Okay. Well, you have to think that each round is a set of games. So in the first round, if there's 512 let's try that again. If there's 512 participants, well, each game is going to involve 2 participants. So that means there's only going to be 256 games in round 1. Okay. Now, after the first round, half of the participants are going to get eliminated, right? So now there's not 512 participants, there's only 256 participants in the second round, which means there's only half as many games because each participant, or in each game, there's 2 participants. So there's only 128 games in round 2. Okay. And then if there's only 128 games in round 2, well, only the winners are going to participate in round 3. So only 128 people are going to participate in round 3. Well, that means there's only 64 games in round 3. And this is going to continue until you get to the very last game, right? You have the quarterfinal or the semifinals, which is like 2 games. And then this is the final game. And this is last round. And we want to know how many games in total. Okay. So essentially what we're doing here is we're going 256 plus 128 plus 64 plus 2 plus 1 equals what? Okay. So this happens to be a geometric series because the terms form a geometric sequence. Okay. So T1 is 256. R, these we keep multiplying by a half. They keep halving. Okay, so R is a half and Tn is 1. And we want to know what's n. So we have to do sort of the same exercise that we just did in the previous 2 questions. We are going to end up with Tn is 1. And that's equal to, actually, I'm going to write out the whole formula because it's hard for me to fill things in without having it down there first. Okay, let me actually just start from the beginning. Tn equals T1 times r to the n minus 1. Okay, so Tn is 1. T1 is 256. R is 1/2 to the n minus 1. Okay, so I'm going to start by dividing both sides by 256. And I get that. Okay, now if I keep multiplying a half by itself, 256 happens to be a power of 2. So I need to figure out what power of 2 is 256, and then that's going to be my n, right? Because it's like, if I square a half, I get a quarter. If I cube a half, I get an eighth. So these values in the denominator sort of mimic the powers of 2. So I'm just going to play around and say, okay, what's 2 to the power 6? That's 64. That's too small. What's 2 to the power 8? 2 to the power 8 happens to be 256. So 1 over 256 is going to be 1 over 2 to the power 8. And that's 1 over 2 to the n minus 1, which means that 8 equals n minus 1, which means n equals 9. Okay, so the question asked how many games are there in this Scrabble tournament. If we want to know the number of games, we need to know what's S9. And S9 is T1, so that's 256, times R to the 9. R is 1/2 to the 9 minus 1 over 1/2 minus 1, R minus 1. I just said earlier that I usually go the 1 minus 1/2 if the values are smaller than 1, and I just didn't do that. But there you go. It doesn't matter. We're going to get the same answer no matter what. And let's work out what this is. So 1/2 to the power 9 minus 1 times 256. So in the numerator, I'm getting negative 255.5 over, in the denominator, 1/2 minus 1 is negative 0.5, right? So the negatives cancel out. So it doesn't matter really what version of the formula you use. And when I divide, I get 511 games. All right, so we are going to leave it there for today, and I will see you guys again